In this section, we're going to take a look at how to set the output voltage and the corresponding compensation settings on the ZL8800. Now, we're just showing one output channel here with the device, but it holds true for both channels. As you can see, the output voltage, we have a differential line sensing directly at the point of load, either at the output capacitance or at the final load. Now, to set the output voltage, there's a couple of different methods. You can use a PMBus command to set precisely the output voltage at the target level you want, or initially you can also use a resistor setting. Now the ZL8800 supports what we call pin strapping and resistor setup. Pin strapping just means that you take the two pins, VSET 0 and 1, and you can tie them high, tie them to ground, or leave them floating to get a combination of the common output voltages, such as 1.8 volts, 3.3. If you need a more precise setting, you can just tie a resistor to ground to the pin, and that sets up a precise output voltage based on the lookup table that's shown in the datasheet. Now that we have the output voltage set up, the next stage is to determine the compensation settings and apply it to the device. The nice thing about the ZL8800 is, with a digital controller, there is no compensation. It's essentially compensation free. The way this works is, you notice our feedback loop. There's no compensation components, no R's, no C's. If you look at the voltage mode controller, you typically have to set poles and zeros in the feedback loop. The ZL8800 doesn't require this. There are no poles and zeros. It's all internally calculated with a nonlinear control loop that we call charge mode control. It's built in with the default settings, so for a common application, you should be able to power up and it will work fine. If you want to make optimizations in terms of transient response, it is possible to adjust the gain and residual settings in the device through the PMBus commands. In the next video sections, we'll go through exactly how to change these and what it appears to be when we look at the waveforms of a load transient on the bench. One of the main benefits of the ZL8800 and the charge mode control loop is the fact that it doesn't require compensation. Therefore, no matter what output stage you use, the device will always come up in regulation and be stable. To showcase this, what we have is a dual channel board running, and we removed all the bulk capacitance except for two capacitors, one pause cap and one aluminum electrolytic. So what we're going to test is, while the device is running a load transient, and we have a 5 amp to 15 amp load step, we're going to disconnect one of those capacitors. We're just going to cut the aluminum electrolytic cap out of the circuit, thereby effectively reducing the output capacitance by half during runtime. The benefit of the ZL8800 is it will automatically adapt to the new capacitance, keeping the device in regulation and keeping the device stable. What we have set up here is the dual channel ZL8800 evaluation board. So we're just going to use this lower channel, which is set with a 12 volt VN, a 1.2 volt Vout. Now as you can see here at the bottom, we have a small pause cap, which is our bulk capacitance, in parallel with the aluminum electrolytic. So we're going to run a continuous load transient with this load box. So to turn this on, as you can see on the scope, we're running a continuous 5 amp to a 15 amp load transient. Now our output voltage deviation during this time looks to be about 20 millivolts. So as we cut this capacitor out, we should have the total capacitance. We would expect a slight change in the output voltage deviation, but we should see the device to remain in regulation. So let's go ahead and pop this cap. So as we just cut the capacitor, you saw the output voltage deviation on the scope did change as a result of less output capacitance. But at all times, the ZL8800 remained in regulation with a stable waveform. Power good remained active, the device was always tightly regulated. Therefore, the benefit of the ZL8800 is it can always adapt to any change on the output filter stage, different inductor sizes, different capacitance values. Even as those change over time, the device will continuously work to adapt to make sure you have a stable output waveform.